Hi everyone, I'm Professor Rad, and today we're going to solve some equations that require multiple steps in order to solve. So, when we are solving multi-step equations, there are, as long as you're using your addition and your multiplication properties properly, there are infinitely many ways to solve equations. So what I'm presenting here are some good steps or some strategies that generally work pretty well. There are some techniques that sometimes will give us a shortcut, but these steps in particular will always kind of give us good guidance. Because solving equations are like undoing operations, you essentially want to apply the properties in the opposite order of operations than you would when you're simplifying stuff. So in other words, normally we do multiplying and dividing first, and then we do adding or subtracting. Here, you'll notice we want to apply the addition property. So you want to add or subtract first, and then use the product property to multiply or divide both sides by something. So you want to kind of be careful about the order in which you're doing your properties to solve the equations. One good strategy is to make sure each side of your equation is in simplest form first, and then at the end, you want to check your answer. The goal of using the addition property is to get everything with a letter on one side of the equation and everything without the letter on the other side of the equation. And then the goal of the product property is to get just like a number in front. Is to get rid of that number in front, rather, of the variable. So we'll work through some examples together. The more that you work on these, the easier they will become. And we're going to kind of keep these steps in mind. Now, for the first few examples, this first step won't apply, so I'm not going to mention it. But when it does apply, I will point it out, and I'll point out how I know when it applies. So, solve each equation below. So when I look at this, when I look at this equation, I make the screen shake. So when I look at this equation, I'm going to think of this as division, not as a fraction. Okay? And I notice that at the beginning, all of my variables are on one side. So like the x is only on one side of this equation. What I want to do is I want to move the thing that doesn't have an x to be on the other side. In this case, this 4. There's no x attached to this 4. So since this is being added, I'm going to subtract it from both sides. And a reminder, when I say both sides, I mean from the number on the right-hand side of the equals and the number on the left-hand side of the equals. This is going to cancel out on the left, giving me just this x divided by 2. And on the right-hand side, 10 minus 4 is 6. Okay. Now, for my next step, I have just the x's on one side and just the non-x's on the other. So all I have to do is get rid of this 2. Since x is being divided by 2, the opposite of dividing is multiplying. So I'm going to multiply both sides of this equation by 2. That will get rid of it on the left, keeping me with just an x. And on the right-hand side, 6 times 2 is 12. So that's going to be my solution. X is equal to 12. Let's do a check. So to check our answer, we're going to substitute this back into the original equation. So I'm going to replace x with 12 over 2 plus 4. Does that equal 10? So in my check, I am going to follow my order of operations. So 12 divided by 2 is 6. And then 6 plus 4 is indeed equal to 10. So it works out. All right, let's try this next question. Looks pretty similar to the last one, kind of, but also a little different. So I've got just a number on the left-hand side, a number, and then a number with a letter. So I want to get rid of this number. Now, by get rid of, I mean move it to the other side, right? So I've got 4 minus 2r. Now, even though the thing with the letter is being subtracted from that 4, what I want to move is not this piece that's being subtracted. What I want to move is this 4. So I could think of this as negative 2r plus 4. In other words, I'm adding a positive 4 here. In order to move it, I've got to do the opposite. So instead of a positive 4, I want a negative 4. I want to subtract 4 from both sides. That's going to go away, and I get 10 minus 4 is 6. Now I have a subtraction of 2r here. What that means is after this 4 goes away, I'm left with a negative 2r. Okay, now I have just a number on the left and a number with a letter on the right. So I'm not going to add 2, okay, because this 2 isn't being subtracted from r. This is a negative 2 times r. So I want to undo that times. To undo multiplication, I'm going to divide both sides by negative 2. When I divide by negative 2, I get just the r on the right, and 6 divided by negative 2 is negative 3. So that means for my answer, I get that r is negative 3. Now, I do want to point out as well, it doesn't matter that r is on the right-hand side of the equation. I could also, like up here in this example, x was on the left. Here, r is on the right. That part doesn't matter. It could work either way. And then let's do a check for this one. So we had 10 equals 4 minus 2r, and r we're saying is negative 3. So order of operations, 2 times negative 3 is negative 6. And then 4 minus negative 6, that's the same as 4 plus a positive 6. So 10 is indeed equal to 10. All right, let's continue and work through a few more examples. And if you're a little confused right now, that's okay. Again, the more of these we work through, the more familiar and more comfortable it will become. All right, for example C, we have n plus 2 times the quantity n plus 4 is equal to 8. This is where step 1 is going to apply. What was step 1? Step 1 said to simplify each side of the equation. So 8 doesn't have anything that we can do to it. But this left-hand side, there's quite a bit of work we can do here. So I'm going to kind of pull that off to the side here, do some scrap paper work, and I've got n plus 2 times the quantity n plus 4. And I'm going to simplify this expression. So to simplify, I'm going to distribute this 2 first. So 2 times n is 2n, and 2 times 4 is 8. And then I'm going to bring down this n here. Then I have like terms, so I have 1n plus 2n is 3n. Then I bring down that plus 8. So n plus 2 times the quantity n plus 4 is the same as 3n plus 8. So I'm going to replace this left-hand side with 3n plus 8. Now I can go ahead and solve. So my goal is I want all the letters on one side, all the numbers on the other. So 3n is the only letter piece. And then this 8, I want to move over here. Since I'm adding an 8, I want to undo that by subtracting an 8. Those cancel out, and I get 3n, and then those cancel out. Oh, okay. This is a common kind of thing that I see on a test a lot, where something weird happens and both of these things have canceled out. On the left-hand side, we tend not to write anything when they cancel out, because when they cancel out, you get 0, and 3n plus 0 is nothing. This is why it's important for your equation to always make sure you're bringing that equal sign down, because when these cancel out, I do have to have something here. And when they're canceling out, they're canceling to give us a 0. So if you get to a situation where one side of the equation is just gone, it's not just gone, there's a 0 there. You use it like a placeholder. Okay, so now I have 3n is 0. I want just n equaling something. So what are we going to do? Well, I have 3 times n is 0. So to undo that times, we're going to divide. All right, let's quiz ourselves. Am I going to get 0 or undefined? I'm going to get 0. So if the 0 was in the bottom, I would get something undefined. So if I had 3 divided by 0, I would get undefined, which would mean there's no solution to the equation. But since the 0 is in the top, I'm going to end up getting 0. So I'm going to see if I can squeeze in a check here. And I'm going to replace n with 0 wherever I see it. So 0 plus 2 times 0 plus 4, does that equal 8? Well, let's follow our order of operations. So 0 plus 4 is 4. I have to multiply before I add. So 2 times 4 is 8. And then 0 plus 8 is 8. So I get 8. It worked out. Okay. Oh, this one is different. The reason I'm saying that is because all of the equations we've looked at so far have had just a number on one side. And this time I'm noticing I've got a number with a letter on one side. And I see that letter is on the other side as well. So what I'm going to have to do here, instead of moving the just number bit, I've got to move this 3p to be over with this 18p. The way that I do that, if I want to move the p along with the number in front of it, I'm going to use the addition property to do so. Since this is a positive 3, I'm going to subtract 3p from both sides. Think of it as you want to be undoing your combining terms kind of situation. So because there's a p here, I want to move this whole term, not just the 3. Okay, so I'm going to subtract the 3p. 3p minus 3p is nothing, so I can bring down the 5. 18p minus 3p is 15p. Okay, so now I have number equal to thing with letters. So I want to get rid of this 15. I want to keep the p here, but I want to get rid of the 15. Since it's 15 times p, we can divide by 15. Ta-da! 0.3 repeating. Let's change that to a fraction. 1/3. Okay. So I get 1/3 for p. If it was a nice decimal like 0.2, I probably would have just left it as 0.2. But since we got a fraction, let's keep it as a fraction. Let's check our answer, especially since we did a weird thing and we got a weird answer. Let's make sure we check this. So 3 times 1/3 plus 5 does that equal 18 times 1/3? So this time I'm substituting this value in for the p on the left and the p on the right. So let's do 1/3 times 3. It's going to give us a 1. 1 plus 5 is 6. Over here we have 18 times 1/3, which is 6. And 6 is equal to 6. All right, excellent. Guys, look. It's a happy face. Okay, so let's go ahead and do this next example. So we have 5t minus 3 equals 11 minus 2t. Oh golly, okay. So I'm noticing that I have t's on both sides and I have numbers on both sides. So I have to make a choice. In this case, I have to choose, do I want the letters to be on the left or do I want the letters to be on the right? It doesn't matter. You will get, or you should get, the same answer either way. So I could choose to move the 5t over to the right, or I could choose to move the 2t over to the left. That's what I'm going to do. So just as we did here, we subtracted the 3p. So we did the opposite of the whole term to move it to the other side. I'm going to do the opposite of the whole term here. Since this is a minus 2t, the opposite is going to be plus 2t. When I do this to both sides, I've got to go to the other side of the equal sign, and I'm going to line it up with its like term, plus 2t. So I'm not lining it up with the 3 because the 3 doesn't have a t. I'm making sure that this guy lines up with this one. That's going to give me just 11 on the right. And then 5t plus 2t is 7t. And then I can bring down the 3. Okay. Just like with those fractions problems, making sure to breathe every step of the way. Now I have t on the left and just a number on the right. So I want to move this just a number. Since it's subtracting 3, I'm going to add 3 to both sides. Gets rid of it. And 11 plus 3 is 14. So notice on this equation, we've now used the addition property twice. The first time was to move the t's to the left, and the second time was to move the numbers to the right. So when you're trying to balance out the letters versus the numbers, you do that by using the addition property. Once you've reached this stage where you just have letters equal to just numbers, now you can go ahead and multiply or divide. So since this is 7 times t, I'm going to divide both sides by 7 to get t equal to 2. Let's do a check. So I'm going to go back to my original equation and replace t with 2. So 5 times 2 minus 3, does that equal 11 minus 2 times 2? Okay. Order of operations. 5 times 2 is 10. And 10 take away 3 is 7. 2 times 2 is 4. And 11, 10, 9, 8, 7. 7 is equal to 7. All right. Let's do one last equation together. So for this equation, we have 2 plus 6h minus 6 is 2h plus 6. Oh gosh. Now for this one, this is another one where step 1 is going to apply. And I know that because when I look at the left-hand side of the equation, I've got a number and a number. And see how they're on the same side of the equation? I can combine these like combining like terms. So 2 minus 6 is a negative 4. And then I have this plus 6h. On the right-hand side, the 2h and the 6 are not like terms, so I'm not going to do anything with them. I'm just going to bring them down. All right, and now we can go ahead and solve. Now, I'll admit this negative 4 is kind of bothering me because it's negative, and I don't want things to be negative here. So I'm going to move the 4 over to the right-hand side. I can do that because I notice that I have h's on both sides and I have non-letters on both sides. So I'm just going to make that choice to move this negative 4 over to the right. Even though I'm adding this to the 6, I have to pay attention to the number or the sign in front. So since it's a minus 4, I'm going to plus 4 to move it to the other side, and I'm going to line it up with its like term. Negative 4 plus 4 cancels out. 6 plus 4 becomes 10, and now I've got this 2h. Okay. Now I have h number, so I got to move this h over. Since it's a positive term, a positive 2h, I'm going to subtract 2h from both sides. 2h minus 2h is nothing. And then 6h minus 2h is 4h. Okay, now I have the h's and the numbers. So 4 times h, I want to undo that times, so I'm going to divide. I get a decimal, but it's a nice one, so I'm going to use that, 2.5. Now I'll point out, if you ended up getting 2.5 or 5 halves, that's totally fine as well. You could get your answer in any format. And let's check this one. So 2 plus 6h minus 6 is 2h plus 6. So wherever I see h, I'm going to replace it with 2.5. 2 plus 6 times 2.5 minus 6. Does that equal 2 times 2.5 plus 6? I don't know. Let's find out. 6 times 2.5, 15. 15 plus 2 is 17, and 17 minus 6 is 11. Two times 2.5 is 5, is 11. Sweet, it worked out. Excuse me. All right. So I've got a few questions for you to try on your own. Solve your equations and check your answers. Remember, you're going to use the addition property first to get all the letters on one side, all the numbers on the other, and then use that multiplication property to get just the number by itself. All right, and guess what? Our next video is the last video of the course. So looking forward to seeing you then one last time. And in the meantime, I hope you have a wonderful day. Bye, everyone.